beautiful people, and welcome. In today's video, we're going to be reviewing how to solve equations. Now, you are expected to have watched all of the how to solve equations videos. So I am going to be reviewing by doing more examples with you, seeing if there's any unique situations that come up that you guys need to be aware of. All right, as always, disclaimer time. I am a human. If I make a mistake, that's okay. Learn from my mistakes so you don't have to make your own. All right, let's go ahead and get started. So example number 1 is going to be a one-step equation. So we have x plus 3 is equal to 8. Now they call this a one-step equation because it does take one step for you to solve. I'm going to be writing down some steps. If you watched previous videos, then you know these steps. I'm not going to be writing down all of them because you are expected to have watched those videos, but I am going to be writing down a few of them. One thing I highly recommend is always draw a dashed line. Now you think you don't need one, however, a lot of mistakes happen when you do the same step on the same side twice because you're not realizing where the equals is. Having the dashed line separates the equation into two parts. On one side you have whatever's on the right hand side, on the other side you have whatever's on the left hand side. Separating them is very important. Step 2 is reverse PEMDAS. So instead of doing parentheses, exponents, multiplication, we want to go the opposite way. Do subtraction and addition first, get rid of them, move everything off to the other side. And our objective or our goal is to get the variable, and the variable is also the letter, by itself. We want to get the variable by itself or alone. All right, let's do that. We've drawn the dashed line. Next, I'm doing reverse PEMDAS. I'm going to put a bubble around my variable. And this way I know exactly what I need to get rid of. Here's my bubble. I need to get rid of that plus 3. Anything outside of the bubble needs to be moved to the other side. So what is the opposite of adding 3? The opposite of adding 3 is subtracting 3. So I'm going to subtract 3 on the left-hand side. Now, again, you have the dotted line for a reason. Let's subtract on the other side. Whatever you do to one side, you always have to do to the other. The best part of solving equations is this part right here. You get to undo adding 3 by subtracting 3, and these get canceled out. You'll hear teachers say cancel out. Now they're not really canceling each other out, but what they are is they're undoing the operation. The opposite of adding 3 is subtracting 3. Now on the right hand side we have 8 minus 3. I don't know what 8 minus 3 is. However, I can count up. I like to count up. So I have 3, 4, 5, 6, 7, 8. I have 5 fingers up. That means I need 5 from 3 to get to 8. So I have 5 left over. Now on the left hand side, what is left over? Is there anything that we didn't touch? Absolutely. This bubble is still there. So I'm going to bring down the bubble. I have x. Now I did make the dotted line a little bit too long for my liking, and it is marker, so I'm going to just use whiteout, rewrite it. X is equal to, remember the dashed line just represents an equal sign. X is equal to, there's 5 on the right hand side. Now again, if you do a step and your variable and your letter is not by itself, it's still attached to something, that means you are not done, and you repeat your steps. So x is equal to 5. In this case, we are done. X is by itself. All right, let's do another example. We have 5x minus 2 is equal to 13. Now this is a two-step equation because guess what? It's going to take 2 steps to solve it. Step number 1, always do the dashed line, dotted line. Not going to make mine too long this time. Again, put x in a bubble. X is in a bubble. Everything else needs to be away. So how do I get rid of, again, reverse PEMDAS? So I do adding, subtracting first. Here's my subtraction. I need to get rid of minus 2. What is the opposite of minus 2? And that is adding 2. If I do something on one side, I have to do to the other side of the dotted line. I'm going to draw my line underneath. So I have on this side 13, 14, 15. This is the best part. We're going to undo this by canceling them out. So what am I left over here? I am left over with my 5 and my x. In this step, I did not touch the 5, and in this step, I did not touch the x, so they get brought down. Now, did we reach our goal? Did we reach our objective? Is the variable x, is x by itself? No, it is not. Because it is not by itself, we have to redo it. Now we have to do the opposite. How are 5 and x attached? So I have 5 here, and I have x here, but what glues them together? How are they attached? And if you're in my class, you know that mathematicians are lazy. Anytime you see a number next to a letter, that means there's a secret multiplication bubble there. Mathematicians are lazy, so we don't want to write that bubble, but as mathematicians, you understand that there is a bubble in between a letter and a number that are put together. How do we undo this? This is 5 times x. What is the opposite of 5 times x? The opposite of 5 times x is divided by 5. So I'm going to say 5 divided by 5. I still have my x. I didn't touch the x. I have to bring that down. And I do what I do to one side, I have to do to the other. So now I have 15 divided by 5. Let me see if I can do that in a different color. I did divided by 5 on the left-hand side. I did divided by 5 on the right-hand side. Same step is I took whatever was there and I divided. So again, best part, that gets crossed out. I still did not touch my x. My x gets brought down. 15 divided by 5. How many times does 15 go into, how many times does 5 go into 15? Or you can say 5 times what is 15? 5 times 3 is 15. And what did the dotted line represent? The dotted line represented an equals. Did we reach our goal and our objective of having x by itself? Is x alone? Yes. That means we are done. So we're going to put our answer in a box and move on to our next example. I'm going to get a new sheet of paper. This one's all written on. And let's try a multi-step equation. Let's try solving a multi-step equation. I got 4y plus 2y minus 76 is equal to 3y plus 11. Now don't let this scare you. The steps are exactly the same, except now we have one additional step. Step number 1, always dotted line. Let's use a different marker for that. Step number 2 is going to be combine like terms. So like terms are the ones that share the same letter. And then this one here, no exponents. That means there's not a little number up top. So we're going to combine like terms and see which ones share the same letter. So let me get a highlighter here to identify which ones share the same letter. So I only see one letter. I see a Y here, I see a Y here, and I see a Y here. So that means all of those highlighted in yellow are like terms. Now also like terms are the ones that don't have any lettering next to them. So we also have like terms of negative 76 and positive 11. Notice that I took the sign that was in front of it. For example, 11 has plus in front of it, 76 has a minus in front of it, and 2 has a plus in front of it. Those symbols belong to the number. 3 and 4 doesn't have any, or 3 and 4 don't have anything in front of it because mathematicians are what? Lazy. We don't want to write a plus here and a plus here. That looks weird, so we choose not to write anything. However, 4 is positive, 3 is also positive. Let's combine like terms. So this one says if I have 4 y's and I have 2 y's, how many y's do I have? Well, if I have 1, 2, 3, 4, and I have 2 more y's, how many y's do I have? 1, 2, 3, 4, 5, 6. I have 6 y's. Did I touch my negative 76? I did not. My negative and my 76 gets brought down. Did I do anything on this side? Is there anything I can combine on this side? I have 3y's and 11. Unfortunately, I can't combine them. One's orange, one's yellow. Different terms. They are not like, so I'm just going to bring both of them down. 3y plus 11. I'm going to extend the dotted line since we are working with a multi-step. It's going to take us a little bit more room. All right, at this point, you may choose what to do. It doesn't really matter what you choose. However, I always don't like negative numbers, so I like to get whatever's negative, turn it into a positive. Now, how do I do that? I'm doing the opposite. So if I have a minus 76, I want to add 76 to both sides so I can combine like terms. Again, we're really happy. Minus 76 plus 76, that goes away. Notice how I wrote my 76 underneath my plus 11. That is because they are like terms. I cannot combine something without a letter next to something with a letter. I can't combine those two. Those two are not like terms. However, no letter and no letter can be combined together. So what do I have here? I have 11 plus 76. 6 plus 1 is 7. 7 plus 1 is 8. That's done. Did we touch our 3y? We did not, so I'm going to write 3y. Now, 87 was positive or negative? It was, in fact, positive. Did I touch my 6y? No, I did not, so I'm going to write 6y here. Now, is there anything else that we can combine? Is there anything else, or are we done? Did we reach our objective? So what is our objective? Our objective remains the same when we're solving equations, and that is get your letter, get your variable by itself. So I see a letter here and I see a letter here. So are they by itself? No. So we need to get the lettering all on one side. So I need to get my 3 to the opposite side. So what do I have? What do I have? This term right here. What do I have? 3y's. What is the opposite of having 3y's? Not having. And if you don't have or take away, that is a minus. So I want to get rid of my 3y. And I do that on both sides. Best part of solving equations, you have 3y's, you take away 3y's, you are left with nothing. This is also called a zero pair. You have 3, you have minus 3, those make up a zero pair, 3 zero pairs actually. So 6y's and I take away 3 of them. So let me show you how this looks like. I have 6y's, 1, 2, 3, 4, 5, 6, and I want to take away 3 of them. 1, take away. 2, take away, 3, take away. I have 6y's, I take away 3y's. What am I left over with? I am left over with 1, 2, 3. 3 what? 3 y's. Again, dotted line represented in equals. What is left over on my right-hand side? 87. Am I done? No, because did we reach our objective? No, we did not. What is our objective? Our objective is to get y by itself. Is y alone? No. So how do we get rid of it? Well, here is my y. How is it attached to 3? Just like in the previous example. These two are attached by multiplication. We're just too lazy to write it. How do I undo multiplication? I hope everyone is screaming at me. Division. So we're going to take 3 divided by 3. And then on this side, take whatever you have and do the same thing. If I divided by 3 on one side, I have to divide by 3 on the other side. Notice how the y did not get touched, so I'm just going to bring it down here. Best part of doing an equation, this gets undoes each other. That's 1. So I have y is equal to whatever 87 divided by 3 is. Now we can't do this without a calculator, so let's go ahead and do it. 3 goes into 8 how many times? You can do it this way. I prefer not to write it out like this. I just like to do it vertically. 3 goes into 8. Well, 3 times 4 is 12, so that's too big. 3 times 3 is 9. That's too big. So 3 times 2? 3 times 2, 3 times 2 is 6. 6, 7, 8, that's 2. We're going to subtract. We're going to bring down my 7. 3 times what is 27? 3 times what is 27? 3 times 9 is 27. I get 27. My remainder is 0. I'm going to bring my answer here for 29. Now, are we done? Did we reach our goal? Yes. Finally, we can put a box around this because our objective is to get y by itself. Is y by itself? Absolutely 100% yes, it is by itself. Therefore, we are done and we have solved the equation. All right, guys, this wraps up this very brief video of how to solve one-step, two-step, and multi-step equations. If you have any questions, reach out to me. Have a great day, and I will see you in my next video. Bye.